Welcome to release webinar of MIDAS Civil 2016 version 2.1 and the new feature PSC Composite Bridge Design and Load Rating Check. My name's Jin and I am Technical Support Engineer at Microsoft. Thank you all for joining the webinar. Composite Girder module was developed in 2015 and has been the most powerful and favorite tool among our users. Steel and pre-post stress concrete Composite Wizard provided our users head start platform and its post-modeling flexibility differentiated our software from the others. Just to double check, everybody can hear me clearly, right? Can you guys raise the hand? All right, thank you. Composite Wizard can run automatic checks for these sections under ASH.LRFD design code. There will be steel composite, PSC composite, RC piers, and cross frames, also known as steel members. And new design code, Canadian code, is currently under development and will be implemented to our software by August 2016. Now I would like to introduce the Composite Wizard. Upon the basics of Steel Composite Wizard with 4 tabs, we added one more tab to PSC Wizard, PSC Composite Wizard, which is Tendon. Please let me briefly describe the functions of each tab. Layout tab covers the overall dimension of the bridge. Girder types, modeling types, span information, and horizontal curvature. Additionally, it can also define the substructure with user-defined dimensions, which basically means that users can model superstructure and substructure within the single dimension input window. Section tab describes more detailed structure of the bridge, such as girder distribution, diaphragm definition, girder dimension assignment. Tendon tab provides user-friendly input table for tendons with various tendon types. Load tab, user can define load cases for pre-composite, post-composite, and live load. Under the construction tab allows our users to set appropriate durations per each construction stages and define concrete pouring sequence and temporary supports in case of splice girder bridges. Now, I would go into more details for each tab. So layout tab. There are 2 girder types provided in our wizard, precast and splice. Following dimension input windows such as the girder alignment or reference support and the spacing options will be determined by the girder types. And modeling type determines the element type that will be used in modeling. Here, right now, you see all frame, but there is actually one more option, which is girder as frame and deck as plate. For precast girder bridges, user can manually determine the gap distance between the spans. For horizontally curved bridge with single radius, user may check the box and input the radius. In cases of multi-curve bridges or complex structure bridges, user can always select the multi-curve option and model the model the structure using a coordinate system in reference to station information. Now I would go on to section tab. User can determine structure details under section tab. Number of girders can be defined with offset distance from the reference line. Reference line is determined in the layout tab. Girder section property can be assigned per spans. Intermediate bracings, also as known as diaphragms, can be assigned in distance input or division per spans. Also, 10th point generation option can be checked or checked off in this tab. Finally, third tab, which is Tendon. Tendon tab will expedite the modeling process of our users by a lot. Visual display of available tendon types is provided under guide button on the top to reduce the confusion for the first-time users. Tendon definition table is very straightforward from left to the right. Users select type, tendon type, select the tendon property, type in total number and distribution distance of tendons, and assign the offset of tendon from the exterior surface of the section, which is H1, H2, H1 and H2. This input table can be a bit hard for the very first time users, so we also provided default input table for bulk T girder section, which is the most default PSC section used for the girders. Load tab generates and activates selected load cases for pre-composite, post-composite, and additional loads. User can also select the moving load code or moving load can define moving load case and moving load lanes and vehicle loads. Finally, on the construction tab, construction stage tab, suggested sequence is provided under guide button. I'll show you in a minute during the demonstration. For splice girders, concrete pouring sequence and temporary support location setup are available on the top. Here is the design dimension for today's example bridge model. It has the girder section is being used with girder section is Ohio DOT B32-46 PSC box. There was no specific reason, but I just chose it. 3-span bridge, 80 feet, 100 feet, 80 feet. Total slab width was 22.5 feet. Per radius was 500, and skew angle was 30 degrees. Now I would like to switch off to our program and then describe each features or each tabs in more details and the preliminary steps they require to use the wizard. Just give me a second. So this is the template file that I created. Right now it has the material property and the section properties predefined. So for the first time users, this is how it looks like when you open up the MIDAS Civil and open up the new project file. This is called excuse me. This is called the ribbon menu. It basically lists down all the modeling steps from left to right and from top to the bottom. So user can select which viewpoint or which elements to activate or deactivate, and user can also define the display options. Structure, it goes into it actually directs straight to the wizard options, and grids or other necessary options for predefining the structure. Node and element, creating the node, creating the element, translate, divide, which is one of the modeling approaches in MIDAS Simple. Properties, where users can define the material property and section properties. Boundaries, where you define the supports, or where you can define the links, different types of links. Under the load, we have static load, dynamic loads, sediments, pre-stress, construction stage, moving load. Each options contains the necessary components for the specific load cases. So if you select moving load, we have traffic lanes, traffic surface lanes from left to the right. It's very in order for our users to use the program easy and at the most convenient way. Analysis, different types of analysis are provided, and results after performing the analysis where users can check the results. So I would like to go to properties, where the first thing you notice, the material properties and section properties are predefined in the template file. So if I open up the material property window, user can select. The first thing, if you select the material property, material ID will be automatically assigned from starting from 1. Unless user specifies, program will generate the material property name followed by the selected material properties. In MIDAS Civil, we have steel, concrete, SRC, and SRC options, and broad database for each material types. As you can see, if you can't find your preferred material property, you can always select user define, which will activate these windows, and you can manually define your own material property. Let me then go to section property. We have DB user, where you can find the most of just regular sections. If you go to value, you can actually manually define them with the numerical values, SRC, combine, PSC, taper sections, and composite section. So the preliminary step for the PSC composite is user need to have the composite section defined. So this is the one of the composite section that I used. I would like to just go over how to set up a PSC composite section using the section properties from our database. So go to PSC section, and let me just pull up our database. So go to PSC value, section data, and DB. United States. Here you can see we have database of a lot of DOTs. These DOTs are actually our current active users. If we could add more, which means if we get requests on the DOT specific sections, we will work on it and then add them in the program in future. Let me just choose one bulb T section. Okay. Just for the default, just put all the lines and click apply. And here you can see LG 63 was generated. And let's go to composite. And go to I, input, a second, PSC, import, and you will be able to see that the PSC section that I just defined on the list, and click on it, and you'll be able to define the slab section on top of the predefined PSC section. This is how you generate the PSC composite section using PSC sections from our database. If you want to do it manually, you can do it manually. The easier way, well, if you have some abnormal PSC sections or some user-defined sections, you can always use our SCC file, which is the section specific file, and import it from the SPC. SPC is the tool in our program which user can generate the user-specific section, and then the section property is automatically calculated. So this section was actually generated using the same procedure. So B4236 and B4236 composite. All the other things are pier caps, diaphragms, and these are the example PSC composite section that I just created. Okay, now let's go to structures, the actual PSC Wizard. You can find the PSC Wizard under Structure, Wizard, and Pre-Stressed Composite Wizard. Okay, so Layout tab. Under the Girder types, users have precast girder types or splice girder type. And once you select the splice girder type, the options automatically change. Span information, you can just type in using commas, or if you have duplicate distance or span information, you can always use shortcut inputs. Layout offset, which is it's explained it's explained on above figure. Layout offset, you can offset the reference line, which is as a default, it is set on the girder, the center point of the girders. Support skew angle, modeling type. Modeling type, you have all frames, deck as a plate, or girder as frame, as I explained. And deck width, and the spacing between the girders, and spans, boundary and substructure. You can build a bridge with substructure, and always when you click the guide button, the visual display will pop up to enhance your understanding or reduce the confusion in the modeling approach. And if you want to define the stiffness of the bearings, you can always usually define it. Piers, you can select material, you can select the section, you can select the column section also. You can also define the height. If you don't want to use the substructure, you can check on the without substructure, and then either select supports or elastic links. Now let's go to section tab. Deck thickness is defined in this tab. You can choose the materials for deck, girder, and diaphragm. The number of girders can be modified here, and if you click on the guide, as explained, it displays the visual aid for the girders. Diaphragm information, intermediate spacing, you can either choose distance or division per span. Transverse deck element, you can choose the distance or divisions. Divisions means division as the whole bridge. Divisions per span means just divisions per span. Here you can assign the section property, girder section properties specifically per spans. Let's go to tendon. Oops. Yes. On the tendon tab, the visual display is provided in order to improve the understanding or reduce the confusion. You can name the tendon assignment name, choose which segment, which span that you are willing to define the tendon sequence for as a reference line. This is the vertical reference line. On the center, or left or right. Tendon shape, tendon type, tendon property, number of tendons, transverse distance. You can just modify it, and the H value defined in H value. You can search on the visual aid, and detail the tendon input table for the bulb T section is provided in here. Now go to load. Pre-composite load cases are provided with the user input window for the numerical values. If you check off, it's deactivated. If you check on, it will be added to the construction stages accordingly. Post-composite loads, wear and surface load, and utilities. You can also select all the provided moving load codes from here. Let's click on the LRFD. Okay. And you can generate the moving lanes in reference to the left point of the bridge. And define vehicles, it directly guides you to the one of features under the load and moving load. It's the same tab, and if you click Add Standard, it automatically guides you to the appropriate selected moving load case. Under AASHTO LRFD, we have HL93 truck, which is the design truck, and tendon and fatigue load. We also have various moving load code available for users. AASHTO standard, you see a lot of DOT loads, very similar to the section properties. Once we get the request for DOT load additions, we work on it, we verify it, and then implement them to the program as soon as possible. Let's just, for example, let's choose Wisconsin DOT loads, Rhode Island DOT loads, Rhode Island permit loads, and operating loads available. For specific cases, let's say if you are designing a moving load case for the trains, we do not have ARIMA, but we do have CE80. Some of the moving load cases, not the moving load cases, but vehicle loads that we do not have in our database, you can always use user-defined and add truck and lane load, or train load, or permit truck, which gives you more freedom on choosing, defining the axle load and choosing the distance between the axles. Let's go to construction stage. Construction stage guide. This is the visual aid that I explained in the PPT. So it shows the most appropriate or the default construction stage that our wizard will generate. These options are turned off because I selected the precast. If I select splice further, it will be turned on. And for the splice girders, let's go to the deck pouring sequence. So you can see that girder stage and which girders that you want to activate at that stage. You can always select them. You can basically make your own the concrete pouring sequence. Temporary support positions, splice support condition, and using false work. This is available. Post-tensioning pendants are also available. If you would like to define the reinforcement, you can also define the reinforcement in the wizard too. For now, in favor of the time period that we have, I've already defined the wizard file. This is also one of the cool features of our wizard. Let's say you input all the numerical dimensions or selected options. You define it all. You're good to go. You save it. You save the wizard file, and then you can bring it for the future reference or future usage, or there is always there's always modifications or additions made on the project file. So save the wizard file and then run the analysis. If the analysis doesn't comes out reasonable, you just open it up again on the template file and then run it, and it will generate the bridge within seconds. Okay, yes, I've said a lot, but I just want to double check in between, in the middle of the presentation. So everybody hearing me clearly, right? Please raise your hand if you guys do hear me. Thank you, Adam. Okay, performing an analysis does not take very long time, but also in favor of the time period that we have, I prepared a model file that already has all the required features performed. So let's go to let's check some of the results values. Go to result, forces, beam diagrams. Let's choose the maximum moment diagram for HCL 93 truck, and it displays the moment diagram. One of the features very handy in MIDAS Civil is activation selection of the elements. So I think a bit too quick. This is the shortcut. So this bar has all the features that's the most widely or most frequently used by users. Select by single, select by window, select by polygon, or select all. Here you can find activate, inactivate, or activate all. If you want to go to pre-analysis stage, which means not the post-CS, but before the analysis was performed, because if you make any modification on here, or at the post-CS stage, you are not able to, some of the features are not able to get modified, so you need to go to pre-processing mode. You can just change to pre-processing mode. So let's click on the select by window, and let me just pull that beam diagram one more time, and select the elements, and activate. And I am reviewing the moment diagrams on the selected elements only. Right. Let's go to design. Yes. Let's go to. Well, actually, let me jump back to the PPT file where the basics of the PSC design check and load rating is described. Yes, PSC composite design check and load rating. So after this, I'll go back to the model, and then I'll go back to the model and briefly go over the features that are explained in this PPT. Under the design check parameters, user can assign different material for girder and slab separately. Interface shear option considers considers the interface condition defined in AASHTO 5.8.4.3. By user selection, program will automatically read off the corresponding coefficients and will apply to the calculations. Also, shear reinforcement is manually defined. Shear reinforcements for the surface, the interface conditions will be defined on this window. These are the items that our software checks using the design check feature. For the strengths, flexural strength, shear strength, and combined shear and torsion. For stress, sectional principal stress per construction stage and under the surface load case. And tendon tensile stress is also being checked. Crack width under the service load can be also checked. As you can review from the table, our program gives very detailed table with load combination, result type, check status, and corresponding result components used in calculation for the check. Design result report is known as design report. Design report is the most comprehensive output that MIDAS Civil can provide to our users. It literally composes every step stated in the design check and displays detailed calculation for our users to determine at which element under which check in which calculation that section property is failing or had failed. Everything is clearly stated with AASHTO design code as a reference. So as you can see on the figure, this is basically straight off from the design report. It gives out the AASHTO LRFD reference equation, and it shows whether it's NG, no good, or it's good. And it shows detailed calculation steps that's been taken. It does not give the functions or the equations that's been used, but it will give you the final product of the check. PSC composite load rating. Although load rating setup parameters are very similar to some of the design check, something like material definition, element assignment for performing the check and providing the results. There are some additional input windows that's necessary for load rating. Rating group is compatible with the structural group. This may not mean a lot, but it means a lot because you are only defining a single group of elements for both analysis and the ratings, which means those results are interrelated and being used with the compatibility within inside the program. Some of the DOTs specifically required the adjacent moving load effects, so it's been added on the it's been added when the steel composite module first came out, but it is provided down there. Unlike design result table, these are the items that our software checks using load rating features. Summary result table summary result table provides summary table for limit state stress, service limit state, strength limit state, rating factors for concrete stress, pre-stressing tendons, flexural shear strength, and shear limit state, and detailed table for rating factors. Yes, summary result table, the one in the bottom, provides which element is being checked under which group, and for which the composite part. I mean by for the composite part, it has girders, and the slab right now is showing as the composite girder. For either tension or compression, and under which rating case, and the calculated rating factor, and the check status. The load rating report provides a table of moments and stress values that are pulled out from the analysis results. As you can see on the top, all the descriptions for each components are well described. Now let me go back to the model file and then go to get down the design parameters one by one. So if we go to for the PSC composite, it's under the PSC. Let's go to parameters. Here you can check the tendon types, exposure factor for the crack width, and output parameters. Whether you check these or uncheck these, the design outputs are different, because if these are not checked, program will not consider those checks, and they will not perform the design check. Corrosive condition, flexural strength, and construction type. And we also provided well, here's the available design code. As you see right now, it's showing ASTO LRP 2014, but they'll be added to our software later this year, or hopefully as soon as possible. Okay, let's go to PSC design materials. Yes. Give me a second. Yes. As of now, the PSC, I was using the beta version, and I did not have some of the features available on the regular version. So I'm back on the correct version of it. As you select, it has girders and slabs separately. User can select the material property from the database provided, and then also for the rebars. Design output positions, that's where users select which element to perform the design check for, and then display the outputs for. Sometimes users perform design check for all the Girder elements, and then after performing the analysis, they only need to see certain elements, or performing design and generating output is two separate things. So which can reduce the amount of time taken in the generating reports or generating the tables. PSD Segment Assignment is available. Concrete allowable stress load stress load cases. These load cases are automatically generated. Once you go before or after performing analysis, if you go to results, go to load combinations and concrete design. Right now I deleted all the load combinations. If I go down to auto generation, in this window, select the design code and the load case types that you would like to consider. Let's just select static and construction stage load cases and click OK. And program automatically generates all the necessary or required load combinations for the design check and load ratings. You can always manually modify these coefficients. If you go here, your manual modification is available. Even you can choose the load cases that you would like to include in the design check and load ratings. If you have if you have the long list of load combinations, you can always convert. These information to the MCP format, which is the text input format, and then right now you see these information written as the text format, but once you write all these down and then open up using browse, it will be automatically added to the program. So that was the allowable stress load cases. Interface share. So here it is where the ASTO 5.8.4.3 is being considered. I actually prepared the specific section. It's cohesion and friction factors. So program will automatically read off these values according to the type of the interface condition that you selected, and then will apply to the calculations. And shear reinforcements, user need to manually select, either selecting the diameters, the number of the reinforcements and spacing, and the strength for the reinforcement. And performing design. Performing design and checking the result table will provide you very similar the result table that I presented in the PPT. Let's go to ratings. A rating for the PSC composite is under ratings, not in the PSC. Rating parameters. You can select the flexural strength limit state, shear strength limit state, service limit state, and put the design load stresses. these are just default values that I input in order to include them on the result table, so please disregard these inputs. Go to rating groups. As I said, they are compatible with the structure groups that's generated by the wizard. Rating materials. So very similar to design material selections. It's divided into girders and slabs. Define the rating case. For the service limit state and strength limit state, the primary vehicle load case and adjacent vehicle load case. And as very similar to design check, if you set up all the parameters and then run the the load rating, it will perform and then generate the result table very similar to the one that I showed in the PPT. So that's basically all the details and everything that our design check and load rating will provide or generate as the outcome, as the output of our software. A lot of our new and existing users had already benefited from the composite girder module for the steel composite bridge when it first came out. That was the main thrust for 2015, and I'm pretty sure that this PSC Wizard will PSC design check and load rating will enhance your modeling approach and your work productivity. I'm very glad to introduce our PSC composite design check and load rating feature to all of you attendees. And thank you one more time for joining this webinar. If you have any questions or if you have any questions regarding the composite girder module or PSC design and load rating check, please send emails to midasit.com. Or if you have any technical support questions, either send email to ts@midasit or use our web board that's prepared for submitting the technical